Thank you very much, Suzanne. Thank you very much. And welcome, everyone. I'm happy that you guys are taking time to join us in this webinar. And just as I was preparing for this, I was looking through some really old Affiliate photos, and I saw that the very first Affiliate meeting, Bill was at it, was at that meeting. So he's been in our region, teaching, helping to build capacity for 25 years. So trust me when I say that, you won't find a better person to help you understand this issue of developing critical internet infrastructure, not just from a technical perspective, but the politics and the policies, and he knows quite a few places where bones are hidden. And of course, joining me is our data wrangler extraordinaire, Amrish. So I'm going to start by asking each one of them, Bill and Amrish, what is your most remarkable story about the impact of failure in critical internet infrastructure? Bill, you go first. 1 minute.
Sure. This is a story that doesn't have anything to do with black swan events or crazy viruses or anything like that, but it's, I think, illustrative of how internet infrastructure can be hugely affected by small things. Back in 1994, when the internet was not quite as big as it is today, there were a lot more protocols in use on the internet. Now everything is IP and Ethernet, but then there were a lot more protocols, and the internet service provider I was running used a lot of frame relay, which was a different layer 2 protocol, a very nice one, worked very well. As long as you were careful and were paying attention, it gave you many, many benefits that Ethernet doesn't. And one of the things that was really good about it was that it provided a good way to interoperate between a service provider network and a telephone company network and other telephone company networks beyond those. And where I was at that time, there was a single incumbent phone company in California in the United States, and that was called Pacific Bell. And they had a network operations center that was responsible for building what were called PVCs, permanent virtual circuits. So anytime you ordered frame relay service, you would build a PVC, which is a lot like a VPN, across the frame relay network. And so they had, something on the order of 100,000 of these built across their network. And most of our customers as an internet service provider were connected to us because the phone company was an incumbent through the incumbent phone company using frame relay. And so we were the second, either the first or second, depending, largest customer for frame relay of the incumbent phone company, the other one being a bank that used it to connect all of their automatic teller machines. And the phone company, there was a very strong union. And so the people who worked for the phone company had been unionized for a long time. And the union got good, fairly high wages for the people who worked there. But the phone company didn't like to spend money. So their response, because they couldn't fire people and they couldn't pay them less, was they just never hired anyone new. So they'd gone for about 15 years without hiring any new technicians. So all the technicians who were working, like the very youngest ones, were about 40 years old, and the oldest ones were 65, which was the retirement age. But there were no 20-year-olds, there were no 30-year-olds. And so everybody knew what they were doing. It was all senior people with a lot of experience. And then the phone company realized that the way they could get around this was by hiring managers to do things instead of technicians to do things, because managers weren't unionized. So they started hiring all these kids as managers who weren't paid very much and didn't really know how to do anything, but were very impressed with themselves because they were managers. And so one night in the knock, one of these newly hired managers wanders in with one of his friends and starts showing off the Pacific Bell Network Operations Center to his friend. And he walks up to a screen and says, "Look, and this is where everything is managed from. And you can just, from here, you can do anything. You can select everything. And if I were to hit this delete button, it would all go away. And he hits the delete button. And it deleted all 100,000 permanent virtual circuits. Of course, everything went down. And of course, they had a backup. But the problem is that the backup was of a snapshot, not of the order in which the circuits had been built. And so the automated provisioning system, when you replay the backup into it, it just tries to build them in the order that they appear in the data file, not the order they were originally built. And it provisions them using resources as the resources are available. And all of these had been built by hand, sort of in funny paths to accommodate all of the pre-existing PVCs at that time. So they replayed the backup, and it got about a quarter of the way done before it ran out of resources in a bunch of bottlenecks. And then they tried to figure out what went on and so forth. It wound up, they had to rebuild all 100,000 circuits, getting all of their people to pull double shifts for a week. And a lot of the internet was down for, most of a week because some kid was showing off and showed that he could just hit delete and delete it all. So very small things can have huge effects. That's my little story about critical infrastructure.
Thank you very much, Bill. I mean, you can design the most critical systems, but somehow we still have to find a solution for human stupidity. Amrish, what's your story?
Yeah, so my story would be more recent than Bill's. So if you were on one of our webinars a few weeks ago, we talked about OPKI and the importance of doing proper filtering. One of the incidents we talk about is the YouTube and Pakistan Telecom incident, where basically, the Pakistani government sent Pakistan Telecom a notice saying that I don't want people to view a specific YouTube video. So they say, oh yeah, I know a very smart way to do that. I will just pretend that Pakistan Telecom is YouTube. So how do you do that? It's using the BGP protocol. As you know, the BGP protocol works a lot on trust. I know my provider. I can send my announcement to my provider. So things, and I can trust reasonably well my provider. So that's why things are based on trust, basically. So what happened is that Pakistan Telecom said that, okay, I am YouTube. So they started advertising the YouTube prefixes on the internet. So they succeeded. Basically, traffic going within their network to YouTube was black hole. So people couldn't access YouTube in Pakistan. But one thing they didn't do is they didn't filter out this announcement. So basically, they announced the fraudulent announcement, pretending that they are YouTube, to their upstream provider, which was PCCW, based in Hong Kong. And then, so PCCW also blindly accepted announcement from their client, from the downstream, and then leaked that to the world. So basically, half of the world, I think mostly in Asia, couldn't access YouTube for a while. But the good thing is that this was quite rapidly detected. They tried to do some mechanics, like to advertise smaller prefixes, shorter prefixes. More specifics have more preference. So eventually they managed to fix the access to YouTube, but the damage was already done. So this is one of the incidents that happen, I would say, on a daily basis, route leaks or hijacks, or intentional hijacks. So this actually highlights the importance of the fragility of the internet, and also the importance of building proper filters, adopting the best current practices, whether it is to document your routing policies and implement security mechanisms such as OPKI. So yeah.
Thank you very much, Amrish. And that's how someone got themselves into the history books. I'm sure when we talk about Pakistan Telecom, someday we'll find the name of the guy who actually brought up that idea. So both Bill and Amrish have shared, a story of, how things went terribly wrong because, some critical infrastructure didn't work the way it was supposed to work. And the story I'm going to share with you is not really a story. It's a current event that we're all living. And it is about this small company. So in 2011, there was a Chinese American engineer who left Cisco. He was working on the team that was creating WebEx. And WebEx, for those of you who remember, was the premier video conferencing application. And so this guy left to create some tiny software called a competing software called Zoom. And it did quite well. And last year they went public. And as of January this year, it was $17 billion. It was worth $17 billion. And then something happened. And what was that thing? This pandemic, this black swan event in which we find ourselves. 180,000 people have been infected. More than 7,000 have died. And the good news that quite a few are recovering. But what that happened was that, see what happened. Some event that originated in Wuhan in China, suddenly because of lockdowns or, closure of businesses, suddenly Zoom doubled, almost tripled in value. And as said, last week, it's a $34 billion company. It is worth more than the top 3 US airlines combined. In fact, I am not sure there's any manager with a strategic plan that was created 4 months ago that could have foreseen that, would be in this situation. Right. So this, for me, shows the resilience of the internet and how just critical it has become. And I'd want to give the floor to you guys, the audience. So where are you working from right now? So go to menti.com and type in that code, and then you respond. Where are you working from right now? So go to menti.com. I see 9 people have responded so far. Thirty people have responded so far. $42. So 1 more minute. Yeah, I can see. So, all right. So it's obvious answer. Most of us are working from home due to lockdown, not by choice, right? That's what's happening almost across the world. Now, what are we going to talk about today? Because of this situation, well, you're going to cover three things. We're going to review what critical internet infrastructure is, and thereafter we shall dig into the statistics and see how is this critical internet infrastructure holding up now that everyone is working from home and it's a lot more demand on certain services than used to be 3 months ago. And most importantly, we need to talk about how we optimize critical internet infrastructure in Africa, and then we'll do some questions and answers. I often like to start this conversation by getting on the same page. What do we mean by infrastructure? Now, one of the best definitions for infrastructure that I've come across is from a book called The Prosperity Paradox by a Harvard professor called Clayton Christensen. And he says, infrastructure is a means by which an economy creates, captures, and stores value. Infrastructure is a means by which an economy creates, captures, and stores value. And if you define it this way, gosh, I don't think that in human history, there's been any infrastructure that has created as much wealth as the internet. Just look at the list of the most valuable companies from 1980 up to today. If you go back to 1980, the internet was still quite nascent. So the only thing that closely resembled an internet company then was IBM. But fast forward to 2020, and you find that 70% of the most valuable companies in the world today, most of their revenue would not exist were enough for the internet. So when it comes to when it comes to creating wealth, there is nothing in human history that has come close to the internet. And this infrastructure, it consists of facilities like data centers, power plants, and cable landing stations, and telecom towers. It consists of systems like the BGP for routing, DNS, time, and GPS. It consists of websites like for e-government, shopping, health, education. It consists of the information on those websites, and the networks that distribute this information from one part of the world to another, and the processes used in government by network operators to provision customers, to provision services, and troubleshoot. And also the people who run all of this, because it's quite easy to talk about infrastructure and forget that infrastructure generally needs people to manage it at some point. Now, which means just having access to the internet is critical, but it's just not enough. Right? And this is a screen capture of this is a very popular African entrepreneur. She runs a multi-million-dollar global company out of Africa. And when this whole virus thing started, this pandemic started, and everyone was shutting down, this is what she did. Public service announcement. If you're setting up online meetings with folks in Africa, understand, we don't have unlimited data plans. Internet is extremely expensive and slow. So understand, we can't jump on every webinar, groupthink session, and meeting. We want to, but we might not be able to. And the reason I bring this is because I believe that it captures that. I mean, this is a woman running a multi-million-dollar company, which means that she can afford relatively good internet for a company. And this is a complaint. So having internet access is not enough. So I'm going to pass the question to you. What kind of internet challenges have you faced during this period? So go to that link and answer. What kind of internet challenges have you faced during this period? So type your answer. You've got a minute. Yeah, poor connection, a lot of disruption and instability during online calls, bandwidth issues, low latency, high cost and intermittent. So 1 minute, 15 people. Good. Submarine cable breaks. Kids eating the bandwidth. Good. All right, time is up. So if I could just ask my panelists, when you look at these responses, what comes to your mind? Does any of this resonate? Bill?
Yeah, I think one of the things that we're seeing is that the network was engineered to handle certain patterns of traffic, right? Certain times of day, certain parts of the cities, certain directions, and all of that's been upended. I think people working from home means that homes now need bidirectional symmetric bandwidth, whereas before homes needed downstream bandwidth and didn't really care much about upstream, whereas businesses needed symmetric bandwidth, and the symmetric bandwidth is all being delivered on fiber in city centers, but a lot of the homes are being served using DSL and cable modems and so forth in a very much more asymmetric way. And I think a lot of what people are seeing is that. Also, I think a lot of residential access plans have bandwidth caps or have surcharges for excess usage, and that affects mobile users as well. So we have a lot of people who are using their mobiles much more heavily now, and we have a lot of people running into data caps. So I think that group of problems forms one big cluster here.
Thank you very much. Amrish, any thoughts about the comments you see on the screen?
Yeah, what strikes me is, I would say, the inequality of internet access, especially in our region, in Africa, where I would say most of the internet users are on mobile. So of course, then they have data caps. In most of African countries, data packages are extremely high. So affordability is an issue. So how would you expect a student, for example, to use the internet to do homeschooling, where the basic access to the internet is a problem because, like in some cases, like buying data bundles is not really an option for their parents. So on top of that, of course, our infrastructure in Africa able to handle more load or to serve more of the population that have now moved from cities to the rural area. So all these are questions that I think particular to our continent that needs to be answered somehow, and we shouldn't just do a comparison with the developed world where everyone is on fiber, for example.
Thank you very much for that perspective. And we are aware that a couple of operators have, done things like, zero rate access to certain websites, maybe like educational websites. But that's still, without any warning, it still leaves the fact that most of the last mile infrastructure is relatively underdeveloped in many countries. That now brings us to good. The five elements of critical network infrastructure. The first one is we need to have internet exchange points. We need effective DNS infrastructure. We need competitive local fiber. We need carrier neutral data centers. And we need, of course, I just added this because we need critical operation skills, because if you don't have competent people to run all of this, it's still not good. You're still going to run into problems that are not a result of an equipment or systems, but because of human capability. And so I'm going to ask Bill to go through each one of this in like the next 10 minutes. What is it? What makes this particular element critical? How does it affect the user experience, and how does it benefit the country if you do it well? Bill, 10 minutes.
So I'll start with internet exchange points. If you think of internet bandwidth as a product that's produced and transported and sold, which it is, internet exchange points are the factories that produce the bandwidth. The job of internet service providers is to transport the bandwidth from the exchange point where it's produced to wherever the user wants to consume it, right? The users don't all want to have to go to the exchange point to consume bandwidth, just as people don't want to have to go to a farm to eat their meal. They want the bandwidth brought to them in the place where it's convenient for them to work. So that's what internet service providers do, is they move the bandwidth from the exchange points to the users. But speed times distance equals cost. So the further you are from a functioning exchange point, the more expensive that bandwidth is and the slower it is. And that's why we all spend so much time talking about how necessary it is to get more internet exchange points built, right? So if you think of it as farms, the closer you are to farms, the cheaper the produce is going to be, the less expensive it's going to be to feed yourself and your family, and the fresher it will be. Internet bandwidth is the same way. So we want internet exchange points to function well. We want a lot of internet service providers to be participating at each one, because the more providers there are at each one, the more effective it is in serving the customers of those ISPs. We want them to be close to us. So more of them means close. I'm right now in France, and France has a bunch of internet exchange points, but they're almost all in Paris. And where I am right now, out in the countryside, there's nothing nearby. So the bandwidth here is very, very slow compared to in Paris. Don't hate me for this. In our apartment in Paris, we have a 10 gigabit internet connection that actually tests out at 10 gigabits. And it costs about, I think, 40 euros a month. Whereas here, where I am right now, it's a DSL connection, and it's the same company, same internet service provider, but it costs, I think, about twice that much. And it is about 3 megabits down, I think, and, 3 megabits up, and I think about 5 down, something like that. I don't remember from when I tested it last, but that shows you that even within the same internet service provider, the costs and performance are very, very different depending how close you are to internet exchange points. Also, the degree of competition tends to change a lot depending how close you are to exchange points. So in a lot of ways, exchange points are the very heart of internet critical infrastructure and the thing we most need to look at. Then there's the DNS. If you can't resolve a name, you don't know what IP address to go to. And so there are very few things that can be made to work without DNS, but they're not things that you are trying to do right now. They're things that you would have had to have prepared for in advance, because somehow you would have had to learn the IP address to be able to type it in. So if the DNS fails, you can't bootstrap those kinds of systems. And even if the connectivity is there, you won't be able to use it. So the DNS is another really critical piece here. And it breaks down into a couple of things. There's the DNS systems on your own computer that have to work. Then they in turn talk to a recursive resolver, and the recursive resolver has to be able to go and talk to authoritative servers. So we need all of that to work, and the authoritative servers themselves break down into several levels, from the top level domains, the root, above the top level like the country codes and com and net and .sa and so forth. And then the second level domains that are mostly the companies and businesses, so forth, schools that you might be trying to reach. So all of the parts of the DNS have to be working, but the DNS has a lot of resiliency built into it. So there are a lot of things that can fail in the DNS before things really stop working. Competitive local fiber is a big one. The more alternative paths there are, the more different companies selling access, the more competition there is, the more likely things are to be able to continue working. That story I told from 1994, the reason much of the internet went down was because there was a single company doing that, and a single company doing things one way. If you had competition, a bunch of different companies, there would be a lot of people trying to figure out each how to do it better than the others. These kinds of problems wouldn't have existed. Critical operations skill. One of the problems I see in Africa very often is that as people get educated and get experience, it's very difficult to retain them. A lot of people will gain their experience in Africa, but then they'll be offered higher salaries in Western Europe or the United States or East Asia. And so they'll leave and they'll take that experience that they gained with them. And Africa shouldn't be in the business of exporting people and skills, right? There are a lot of things that Africa could export, but losing people is a permanent loss, right? You only get a few of those people back, and it's difficult to attract other people in to replace them at a similar level of experience. So finding people who are not going to jump ship at the first opportunity and investing in those people is I think a really important part of supporting critical infrastructure in Africa. And then carrier neutral data centers, there's got to be a place to put the content, and the closer those data centers are to people, the better performance there'll be, the cheaper it'll be to get to that content, and the more the content can be sort of customized for particular markets. One of the big problems with data centers is overinvestment. So you find people building really big, fancy, expensive data centers, and then they have to charge a lot of money to be in them, and they can't afford to build more of them. So my thought on data centers is mostly that people need to be a little less grandiose in building them, build smaller ones that are cheaper, that are closer to people, that are more affordable.
Thank you very much. Thank you very much for that perspective. I'm particularly especially love the fact that when you talked about the disparity between the access, the costs in the rural and urban areas. As we know, most ISPs are commercial entities, and they would make the case that it's not commercially viable to offer the same kind of services and infrastructure in rural areas as they do in urban areas. So based upon your experience doing this in different countries, how are the best countries in the world addressing this? Bill?
Wait, sorry, was that to me or to Amrish?
I'm asking you, the issue of disparity in the cost of access in local areas and urban areas. Since it comes down to it's a business decision, I mean, how are some countries in the world addressing this disparity?
So a lot of this comes down to regulatory work. You can regulate prices to the same level everywhere, or you can allow a lot of competition and allow the prices to float. So a lot of modern regulatory policy goes back to the Great Depression of the 1930s, when the US government particularly started to do rural electrification. So they thought that one of the ways they might be able to pull people out of the Depression was to get electricity out to rural areas and modernize farms and make them more efficient and lower the price of produce, of agricultural goods, and employ a lot of people in the process. And that all worked. And one of the things that they did was they essentially said the price of electricity should be about the same on a farm as in the middle of a city, even though it was vastly more expensive to bring the electricity all the way out to that farm. And then when telecommunications followed along suit, along behind, the telecommunications policy people said, well, you did this for electricity, you should do exactly the same for telecommunications, even though farms aren't as dependent on telecommunications as they are on electricity. And every other utility kind of followed along behind that, which means that even though it's really cheap to provide utilities in big cities and really expensive in rural areas, there's this subsidy. essentially, for utilities in rural areas in many countries. And this leads to suburbanification, right? It leads people to move out of cities to places where the land is cheap, but they get all these subsidized services. And this uses up farmland, and it uses up money, and it takes the money from an ever depleting pool of people in the center of the city. So you can use regulatory policy to force prices down in rural areas. But what might work better is to allow more competition in the rural areas and allow, kids on farms to wire themselves up. A good example of that is Barn, broadband for the rural north in England. So northern England is farms, and it's not wealthy, but it's also not regulatorily constrained. So a lot of those farmers get together and they run their own fiber, and they have their own network, and they have tractors, they can dig ditches, they're good at the physical skills of building infrastructure. The pricing structure of that is not the same as you would find in a city. Sorry, I don't have a really clear answer here.
That's fine. I mean, that's enough. Because it's enough to understand that at least there's a regulatory option, and that historically something similar was done for electricity. So maybe there's a model that we can copy. So thank you very much for that. So in a nutshell, the 5 critical elements of a critical internet infrastructure. Yeah, and Amrish?
Yeah, on the same point, like, the disparity between rural and urban areas. Yeah, indeed. So, the internet was initially built on an open source model, but it seems now that as we are moving forward, we are locked down. I would use the word lockdown in that new model where, we need the big 5. We need the Google, the Cloudflare, and so on, for us to have a functioning internet, right? So this is where things have started breaking. Why don't we empower people in those areas to build their own infrastructure, own their own infrastructure, and also use the open standards out there, for example, to have caches and things like that. So, yeah. So it seems that we moved away from the initial, mindset that the internet is a shared commodity, and also a infrastructure that should be owned by everybody and not by just a few. Yeah.
So thank you very much for that perspective. And this is where I probably see the rise of community networks, like what ISOC is doing, and it just needs to be that I hope the governments can put the regulatory framework in place so that people can develop and build community networks. I remember about 5 years ago, there was a policy on the Afinic PDP mailing list about getting resources, securing resources for community networks in Africa. So that's definitely some initiatives like what ISOC does that can help here. So in a nutshell, critical infrastructure is the internet exchange points. That's the bandwidth that's the bandwidth factories. You really want to have at least one within your country so that you're not paying Forex and having unnecessarily long routes to go up to Europe and then come back just so you can get to your neighbor on the next town. You need effective naming infrastructure, not just the root DNS servers, but copies of your CCTL list locally, ideally tied to your internet exchange point. Because the faster you can resolve a name, the faster you can get on with the service. And if there's a significant % of your traffic that is being dedicated to resolving names, it's not really value adding. You need competitive local fiber. I mean, we've been speaking to quite lots of operators, and sometimes the cost of getting local fiber is so prohibitively expensive that people, we'll just buy transit or something like that. And of course, you need carrier-neutral data centers, because without carrier-neutral data centers where people can host content locally, then we are tied into this. Not only are we going to be exporting our skills, but also, we're going to be stuck as perpetual consumers of the internet. Now, let's look at, let me pass on to you, the audience. How optimized is your organization's internet infrastructure? So go to Menti. Good. Go to, yes. So rate your organization's performance on each of these dimensions. And these are the dimensions Bill was just talking about. So 1 minute, yeah. Go to menti.com and you put in the code 853107. 853107. Menti.com 853107. That's the code. So only 22 people. Come on, guys. There are 107 of you in here. Go to menti.com, www.menti.com. It works from your mobile phone too. Menti.com, and you type in the code 853107, and you participate. All right, I'll close it when we get to 50. Yes, and there we go. So if I might ask the panelists, who wants to go first? If you look at this sample of 49 people, does anything jump at you immediately? Amrish, Bill?
Yeah, so I see that we have 3.5. Is it over 5?
That's an average, 3.5 out of it. This reaches 10. 0 to 10.
Yeah, they look at IXP, which is which is not too bad. And then is the traffic resolved in country? That would be an interesting metric. I would say most of the time in African countries, it's not the case. I tend to be corrected though.
I'm happy because you're the data guy. You're going to keep us honest when it comes to this.
We have options of fiber optic access to connect to the IXP. Okay. And then the cost of fiber access is not that affordable, I see here. So I think policy could also help in here to ease access, at least to an IXP, which is a critical infrastructure. So I would say maybe regulators should provide more facilities to connect to critical infrastructures. Yeah.
All right.
I think it's interesting the way these interrelate, right? You see a fair amount of networks peering at the local exchange point, despite the cost of that being a really high thing. And we've got plenty of options, it looks like. That's a 3.7 there. But if they're not affordably priced, then you can't really use them. So my sense here is that if the prices were lower, all of those available options would get used more, and even more people would peer. And then the DNS traffic would be resolved more in country, and it would make more sense to host locally, right? So I think what we're seeing here is one problem that has spillover effects that are making everything else not quite as good.
Yes, and that problem would be the cost of fiber access, right?
Yes, exactly.
Yeah. So thank you guys very much. And so now that's what you think. Now, Amrish, you tell us, what do the statistics say? How is the world's critical internet infrastructure performing during this pandemic?
Yes. Would you allow me to share my screen?
Yes, let me stop sharing and then you can share.
Okay. All right. Let me go full screen. Yeah, you can see that, right?
Yes.
Okay, perfect. Yeah, so let's have a quick look at how networks are performing during this pandemic. Well, first, based on our conversation here today, there is a very interesting graphic that I've got from the World Bank, one of the blogs there, which I really wanted to share with you today about, the state of fiber deployment in Africa, and also the population density. So each cell here is the green, the pale green cell is around 100,000 inhabitants. So you see it moves to the more blue, how dense population is in some areas, but you see gaps, right? Gaps of how people are not connected or at least far from the fiber fiber cables, and so especially in landlocked countries where you don't even have landing ports to carry out traffic, and we usually know in between African countries, usually relationship is not that good in between neighboring countries, and then it also makes things more difficult. Yeah, just wanted to share this piece of information. So about the COVID, we are seeing shifting patterns, of course, because more people are working at home. It means more people are online. They have perhaps more free time to go online. The kids are at home, so they are watching YouTube and Netflix. So we have a few data sources, a few numbers from Nokia Deepfield here, which is saying traffic basically increased by up to 75% in some places. Teleconferencing traffic, so Zoom. So we are doing Zoom today by 300%. Just imagine. Gaming increased by 400%. So of course, this is putting a lot of strain on national internet infrastructure and usually on critical infrastructure. Remember, in some countries in Africa, you don't have an efficient internet exchange point. So the incumbent operator would be, I would say, the critical infrastructure in that country.
Yeah.
The strain sometimes might be difficult for the operators to manage. Thousand Eyes, which is a data analytics company, found that there are more outages during this COVID period. The reasons could be multiple, right? Less people on the maintenance side, because if you're locked down at home, yeah. So the question that we have here: Will your national infrastructure keep up with the surcharge in demand in terms of bandwidth? You might have heard from the news during the pandemic in Europe, and Netflix, regulators, I think, or the government asked Netflix to do some throttling on the bit rate so that everybody can have a fair share of the bandwidth. Yeah, that's an interesting pattern happening.
Amrish,
Yes.
if I could to chime in for just a moment on that. That's actually a really interesting regulatory issue. So what you noticed there was Netflix didn't see any reason why they should need to throttle their own bandwidth, but they were asked to by the European Commission, which is a political body, not a technical body. And so what that actually was is just net neutrality politics playing out, right? So the eyeball networks that fight against content networks in net neutrality lobbied the European Commission to ask that of Netflix, not because there was any shortage of bandwidth. I mean, bandwidth is scarcer right now, but it's not in such short supply that Netflix was having any problem delivering. But because it puts Netflix in this horrible position of having to either penalize their own customers or look like they're not helping with the pandemic, right? So that was a very, very political decision, not a technical decision.
That is interesting.
You know, if in Europe, operators, they do traffic differentiation, would they actually privilege Netflix traffic so that the EU Commission would say that they would like to have more net neutrality?
They deprivilege Netflix traffic unless they're forced to by regulators, right? So the main problem there is cable companies that are providing internet access, but also have intellectual property stables of video content that they want to sell. And so they don't like over-the-top operators selling video content over their network. They want to be the only ones who sell video to their customers. And so they want to penalize other networks in order to either get more money from them or make them look less attractive to customers. That's the net neutrality debate in a nutshell, but that's not really the topic we're on today. I just wanted to point out how there are people using the pandemic to advance completely unrelated policy goals and try and make it look like it has something to do with the pandemic. And so we always have to be careful of that. We have to be careful of bad people using a crisis to advance their personal interests. And that very much happened there.
Thank you very much.
Yeah, and the next slide I had was from Cloudflare, where basically here the green dots represent actually more demand, so more traffic going towards Netflix, and the red dot means decrease in traffic. So it's interesting to see why. That's expected in the US and in Europe, more traffic going towards Netflix, while people, no, sorry, not Netflix, Cloudflare, while people are at home, maybe visiting more content and things like that. But we see a slight decrease in South Africa, so that would be interesting to interesting to understand why there's a decrease in South Africa, for example, during this pandemic period. Next, this is for New York City. As you see, there's a decrease in demand in Manhattan. Of course, this is related to the lockdown where people basically moved out of New York to go to the suburban areas. So Cloudflare was claiming that they had an increase by 33% of internet in New York. That's another graphic from Casper, which is another data house. Here they are measuring internet pressure. Internet pressure is just basically the ratio of latency and new latency that they are measuring during that pandemic period, as opposed to latency that they were measuring before when there were no pandemic. So if you see an increase in that ratio, means you see pressure, you have internet pressure happening, degraded quality of service and things like that.
Quick question, Amrish. I know you and a couple of other colleagues did a research on latency across African networks,
Yeah.
and I'm wondering what's the explanation for the blank, that dark hole in the middle where Africa is supposed to be? Is it that there are no sensors or what?
Yeah, so that one would really depend on the type of the data sources and vantage points. So for example, RIPE Atlas, you could use RIPE Atlas or some other device that you would actually host yourself. So as you know, RIPE Atlas or even some other appliances such as Samnos or from Kada, they are not that well spread around Africa. So that's could be a reason. But I know, for example, these data houses, they have alternative data sources. They might be using Google Ads, or they might be buying data from Facebook or Google.
Okay. So I'm also aware that within your unit R&D, there is some work being done with potentially using RIPE Atlas probes and anchors. Would that be able to help us solve this problem? And who are the people that need to show more interest in this?
Yeah, definitely. This would help us increase coverage. So we might see more blue dots here in Africa than we are seeing right now. The good news is that RIPE Atlas, both the probe and the anchor, because you have two versions of the RIPE Atlas measurement platform. You have the anchor, which is a more advanced probing tool, and then you have the small probes, which would do basic measurements. Both of them now have been virtualized, so it would be, I suppose, more easily installable and deployed in our community. So yes, people who have spare cycles, spare VMs, and capacity, please reach out to us, and we will help you install either a probe or an anchor. And this will help us greatly in terms of data collection and provide you more precise information about the state of the internet in your individual countries.
So to be clear, any individual, so long as you have internet at home, you can host a probe, right?
Yes.
However, the requirements for hosting an anchor are a bit more. Can you tell us a bit more about the requirements for hosting an anchor? What kind of organization are good candidates for hosting an anchor?
So for probes, as you mentioned, anyone could do that. So earlier we were distributing hardware probes. So hardware probes is just a plug and play device. You plug it and play. You plug it in your network, and it works by itself. It would just send data. For example, it does measurement to root servers to understand what is the latency from your network to the root servers. The anchors are hosted mostly by bigger networks. That could be an ISP, or that could be a university, or we also privilege internet exchange points because it means that if you install the anchor at the exchange point, then we have easy access to all the members of the exchange point. Yeah, this is how it's working right now.
Thank you very much. Okay, go ahead.
Bukom, I think we should do a webinar specifically on measurement sometime soon, and we can elaborate more on these different.
Yeah. So everyone who's interested, we'll plan a webinar soon, and so stay tuned. Yeah.
So I did a bit of, I would say, crowdsourcing of information about speed and latency. So, for example, here I got this information from Speed Test UCLA, and they were basically measuring what is the speed. They were actually observing the speed, because this information is crowdsourced. Whenever someone is doing a speed test online, they are capturing this information and aggregating it here. So we have information for South Africa, Egypt, and Morocco, and Algeria, 4 countries that have been in lockdown. And for example, for South Africa, Egypt and Morocco, we have seen a decline. We have seen a decline in the download speed somehow, just after the lockdown has started. So decline in bandwidth might also correlate with the fact that if there is an increase in latency during that same period, that could indicate that perhaps in those networks there is more congestion, so more users, so therefore this can impact quality of service and then therefore latency. They also measured mobile broadband performance, and for example, in Morocco, the mobile download speed decreased a little bit, and then it came up. Perhaps more resources were allocated, or they did better congestion management, etc. In South Africa, which is the green here, the green line, download speed has been going down actually in the last few days of the lockdown. Algeria and Egypt remain stable, except for Algeria in terms of latency actually, where we see even though if bandwidth remains stable for Algeria, we see an increase in latency. Another interesting thing we could have a look at during this pandemic period is traffic levels at IXPs. As you know, IXP, as we mentioned, is a very, is considered as a critical infrastructure. So I was doing a comparison between more advanced countries and African countries. And for example, here, Singapore, the SGIX, we see an increase in traffic over the period of March to April, which is when the pandemic peaked actually, and also when the countries went into lockdown. As you can see, it increases from the average traffic that they usually see on the IX there. Same thing for Taiwan, a slight increase, not that much actually. That could be because in countries like Taiwan or South Korea, they usually mention that these countries handle very well the pandemic, and the impact on the economy and the impact of people being locked down hasn't been that much. That could be a reason. The other reason is that in these countries, networks are very well provisioned, so working from home or not working from home isn't so much of an issue. So the traffic kind of level, so no much change. That's UAE, Dubai, UAE IX. We see quite a big increase here. The country has been in lockdown as well. So that would be interesting to understand why we have such a big increase as opposed to earlier in the year. Coming back to Africa, I've had a look at the Ghana Internet Exchange Point. So as you know, Ghana has been in lockdown since end of March, mostly concentrating on the cities, Accra and Kumasi. We see at the end of March a slight increase in traffic, and then it goes down. We don't have more data, so I won't be able to see what's the tendency further down. We need to wait a little bit. I was also looking at where the CCTLD is hosted. The CCTLD is hosted at a government agency here, which is not even a member of the IXP. So this is a problem, right? So you have critical infrastructures, but not a member of an IXP, where this could have helped actually reduce latency and increase quality of experience in this difficult time of COVID-19. Kenya. Kenya is usually I would say, a good student. We see here a slight increase in traffic ending March 2020 and going into April. Kenya has been into a partial lockdown, not the whole country, but the major cities. And the good thing here is, for example, the .key, the CCTLD is a member of, which is Kinnick, is a member of the IXP. And this matrix here is coming from the IXP JEDI, from the RIPE NCC. And as you can see here, the dark green here is where network are appearing. And basically, you see quite a few networks are appearing and not sending traffic outside of the country, which is a good sign of the health and of the internet infrastructure in this.
So the green dots mean that the data is being exchanged locally, right?
Yes. Correct. Yes. The pale green still means that data is exchanged locally, but not going through the IXP.
Okay. Okay.
Yeah. Uganda IX. This was a very interesting case study where, as opposed to the other places where we have seen that there is an increase in traffic at the IXP, here we see a decrease in traffic. Maybe people here in this webinar can give us a bit more insight about what's happening in Uganda. So I would suspect perhaps most of the traffic of the IXP were related to businesses exchanging traffic. And since the lockdown, maybe activities has been reduced, so less traffic on the business side. So, which now means that people at home might not have access to unlimited bandwidth or cable or wired to the home. They might be on mobile and not using that much internet. I see .uj is anycast through PC.
Yeah, I see that in the Q&A, someone answered in the Q&A is that in Uganda, people left the city for the rural areas, okay. And most of the internet deployments are in the cities. So if people go to the rural areas, you would expect there to be a lot less, which makes sense.
And then I have retrieved some data from a portal called the Internet Health Report, which is here talking about latency. And for example, in South Africa, in the last few days, so this is latency from Telkom, which is, I suppose, one of the most used operator in South Africa. We see in the last few days an increase in latency towards the upstream provider, which is NTT, as well as Hurricane Electric, just a slight increase in latency. The reasons still need to be explained. Maybe we can have insights from people who are from South Africa. Another example would be Rwanda here. We have Airtel Rwanda, where latency towards their two upstream, NTT and Liquid, during this lockdown period has been a little bit unstable. Though if you click on the link there, you will see that it has now stabilized, but there has been a point where there were increase in latency. So these are artifacts, I would say, in the graphs that we need to dig into and see what's
also perhaps the WACS failure, the West African cable system failure. I think that's Telkom's primary way out of the country in South Africa. So that might have had an impact on this.
It might have an impact. You're right, indeed. So a lot of questions that we could actually ask. Some of them more difficult to answer than others. For example, so we basically all want to understand what is the impact of lockdown on the internet infrastructure in the country, right? So are we seeing, for example, more congestion? And that would be an interesting question to answer. There are different techniques we could use. For example, RIPE Atlas itself, and try to see if we have congestion on different networks. The challenge here is to find enough probes that can actually help us answer these questions. The different traffic levels at IXPs can also tell us a story about what's happening in the country, as we have seen for the Ugandan case. Mm-hmm. Yeah, and then also what are the different behavior patterns that we are seeing, as we can expect more Zoom usage, more Netflix usage, more gaming. Mm-hmm. What does it mean to have more of this usage patterns in Africa, for example, and what is the burden on African networks? Are the behaviors the same for users on mobile broadband versus wired, so on? And one thing that could be interesting is to uncover is the traffic differentiation, so net neutrality that we were talking about. So are we or operators in this time of more usage, more heavier usage, are going to do traffic differentiation, so increase or decrease, for example, I don't know, WhatsApp bandwidth and things like that. So those are interesting questions that could be asked to researchers out there. So that's it for my presentation.
Thank you very much for that, Amrish. Bill, PCH runs a fairly extensive network, and I'm sure that the Quad 9, your DNS service, is very, very widely used. Have people seen any patterns around the usage that could give us some insights into things here?
We're seeing the same thing that most people are seeing, which is that internet usage is up. That time shifting a little bit more into the evenings. So we're seeing the morning ramp up being a little slower and the evening drop off being longer and later. I'd say that there isn't a giant effect in the DNS network because there's so much caching that occurs. So we're seeing a little bit more traffic, not a lot more traffic. I don't have the numbers right in front of me, but my recollection was something like 4 to 6% more traffic rather than the sort of, 20, 30, 40% more traffic that a lot of the access networks are seeing on generalized traffic, right? So if somebody does a video conference, it's still just a handful of DNS queries that are very small, relative to, looking at a web page, which would generate just as many DNS queries. I think in terms of patterns, we're not seeing a lot of shift. I was very interested to see the decrease in traffic at UIXP because that's certainly not something that we're seeing at other exchange points. I don't have any big news there.
That's good. Thank you very much. Now, let's go to, now we've already explored the critical infrastructure. You need the bandwidth factories, those are the internet exchange points. You need at least one per country. Ideally, you need one per large city. You need effective DNS naming infrastructure, that is having at least one server of your CCTLD DNS server hosted in the country, preferably at the exchange point. You need competitive local fiber so that different operators can connect to the internet exchange point. You need carrier neutral data centers to host the content so that it's not doing hairpinning run in Europe. I need the critical operation skill. Now, what could we be doing to improve, to fix, improve, or optimize each of these? So I'll start with Bill, 5 minutes. If you had to pick, say, 3 of these things to focus on, what would you want to fix, improve, or optimize?
I think if I had to pick three, I'd be looking for the problem areas more than I'd be looking for the easy lifts, right? So I think the number one there is the competitive fiber, getting more fiber in the ground, getting it to more people, increasing the competition over that fiber. That's really what's going to make the biggest difference. More fiber means the cost of bandwidth goes down. A lot of people think fiber is expensive, right? But what it's really doing is it's making a lot more bandwidth available, which brings costs down, which means that more people can afford to use it. So more fiber, more competition in giving access to the fiber, that's really the number one issue. The data centers, you know, there's some beautiful data centers in Africa that have been built at very reasonable prices. There's one in Enfida in, not Algeria.
Morocco? Tunisia?
Tunisia, yes, thank
Tunisia.
you. In Tunisia, that it's this beautiful data center that cost $3 million to build, which sure, 3 million sounds like a lot, but you know, you compare that to the $300 million that was spent on the data center in Bahrain, you know, for 100th as much, they've got a data center that is giving them 99% of the effective value. And so if you think about what that means, if collectively society had $300 million to spend on this, you have a choice. Do you serve one community or do you serve 100 communities? If you look at it that way, the answer becomes a lot more obvious. The other thing is the number of businesses that can meet a $3 million challenge to go build something is much, much greater than the number that can come up with $300 million to build something. So this sort of overspending on data centers has huge repercussions. It makes everything more expensive for everybody. So more fiber, a lot more smaller data centers at lower prices, not worrying quite so much about all the different expensive certifications that were, you know, designed by companies in the United States and Western Europe to close the door behind them and decrease competition, right? Those aren't certifications that are interesting to you. What's interesting is whether you can serve customers and be paid to do it. So those two would be the ones that I would really focus on. Africa is doing okay on exchange points. You can always do better. You can always build more exchange points. You know, one of the things to look at there is, I believe Tanzania was the first country in Africa to have more than one exchange point. And they didn't view it as a big deal. They didn't, you know, I may be wrong about that. It might have been South Africa with one in Cape Town, but in any event, an exchange point is not something to be reserved for your capital city only, right? You really want one in every city. The part of the United States that my family is from, it's the fourth largest state in the US. It's almost as big as California, but there are only 600,000 people in it. And I think there are 6 or 7 exchange points in cities as small as 10,000 people. So it doesn't have to be a huge city. It doesn't need to be expensive. That's really the single lesson I would try and take home, is that getting the work done and not overspending on it, right? Don't think that you have to have a lot of money to build internet infrastructure. What you need is a commitment to doing the work, not a lot of cash.
Thank you. I particularly love this example of a 3 million data center in Tunisia that optimizes for serving the local market by choosing to forego some of the expensive certifications that does not immediately add any value. In your experience, is that an exception, or do you find more and more data centers being built cheaply without lots of gold plating that way? Or is this an outlier?
I think it is an outlier. I think far too many people look at the data center market and recognize that it's going to be kind of expensive to get into, And then they look at these big, huge companies that are building data centers in Western Europe, in the United States, in Japan, and they look and see that those were, 100, 200, $300 million data centers, and think, gosh, there's no way I can compete in that market. But at the same time, the little data centers that are doing very well in their own markets, they're not advertising themselves in other places. They don't have a giant PR budget. They're not, putting advertisements on Netflix or whatever, to reach mass markets. Mm-hmm. So you don't find out about them easily. So there's an observation bias that happens, and people think only the big way is possible, and they don't see the very successful examples of small data centers that are doing well. So I think Terraco in South Africa has done a reasonable job. I think Terraco could probably have built a lot more data centers if they focused less on certification and on making them sort of big and fancy. But if you compare a Terraco data center to an Equinix data center, Terraco is spending their money much more effectively than Equinix is. So I think there are plenty of good examples, but it's a lot harder to spot them because they're not wasting their money on advertising, outside of their own region.
That is good to hear. So let's pass it to the audience. Last engagement. So you've heard Bill and you've heard Amrish. What's the one thing you think that you could do within the next 2 weeks or 1 month to optimize your network against Black Swan events? Go to Menti and let us know. What is the one thing that you can do? Menti, the code is there, 853107. Move that last server we have overseas into a local data center already in progress. That's right. Better caches. Someone says it's fine as it is. Upgrade capacity to always have 50% spare on all links. Redundancy, right? Increase transit capacity. Only 7 people, come on. There are 90 of you in here, so I want to see at least 50 respondents.
In the meantime, as we're waiting for people to type in their ideas, yes. One of the things that we've found in running our network that's really useful is having sort of one set of approved equipment for every location and have it being the same everywhere, and keeping spares, okay. And not having a bunch of different kinds of equipment for different purposes, just even if what we have is not optimized.
Okay, that's interesting. Someone says they need to catch up on sleep. Learn about community networks and apply them in rural areas. Increase bandwidth. Okay, 30 seconds more, and that will close this. So thanks those of you who have been putting questions in there. If you have any questions, start typing them down in, because after this, we have less than 5 minutes till the end. All right. So if you look at the responses on the screen, Bill, if you look at the responses on the screen, does anything catch your attention? I mean, as someone who's been doing this across, so almost all parts of the world, people are locked down, maybe physical access to things is restricted. What is something that you think that a network operator could do within the next 2 to 1 month? What's something that you think a government regulator could start putting in place to make sure that, when we come out of this as African countries, as African network operators, we are in a position to build more resilient critical internet infrastructure.
So I'm gonna look at a few of the responses here that share something in common and say why I think that they're problematic. A bunch of the people here are saying, well, we should buy more transit, we should increase the amount of bandwidth we're buying upstream. And I recognize that that looks like a necessary thing right now. If you've got a lot of people at home and they are using a lot of bandwidth, then having more bandwidth to give them obviously makes things better. It also costs a lot of money, and you're competing with everybody else who wants that at the same time. It's going to be difficult to get, and the prices, you're not going to get really good prices. If, on the other hand, you can increase peering and at your exchange point, increase capacity at your exchange point, that's not a recurring cost, that's a one-time cost to upgrade that. And that makes better paths locally, which means that people will tend to use more of the local bandwidth, which makes the mix of bandwidth that you're selling more cost-effective for you. And that's something that's not going to change. So you could either be spending more money and not getting any more in, or you could be making a one-time investment that's not huge and decreasing your overall costs over the long term, because with a more efficient traffic mix that depends more on peering and less on transit, you can keep adding customers without having to upgrade your transit as much. So I think that's the thing I would be looking at most here.
Thank you very much. So there you are, gentlemen. There you are. Any questions? There's no question. If you have any questions, you have 1 more minute to type any questions in the Q&A. If you have any questions, type it in the Q&A right now. You have 1 more minute. If not, then I have to say, Bill, thank you very much for taking time to share your knowledge and experience with us. We really appreciate it. And we hope you'll be here for the next 50 years to help us in this journey. Thank you, Amrich, for your insights. And thank you, Nishal, in the background. Susan, thank you for setting this up. And there's Bashir, Willie, who are working in the background to answer the questions and help people connect. So there's a couple of more Q&As. Okay, more questions are coming. From Deole Ajao, so to Bill. Bill, the challenge for most people in Africa is that the same guys selling transit are the ones selling the national long distance that gets to the IX. Bill, do you want to take that?
So I don't know how much of a hurry we're in to shut the webinar down.
I think anyone who wants to leave can leave. If we'll stay for as long as you want to stay. Anyway, I mean, officially, who wants to leave here?
So
yeah.
So yeah, I recognize that there are often these problems of too little competition. Canada is an interesting example where this problem has been really clearly quantified, because the Canadian network operators have done a lot of sort of survey and data collection. And it turns out that TELUS and Bell Canada, the two incumbents in Canada, they peer in plenty of exchange points, but none in Canada. They only peer in the United States. And they're also the providers that sell the long haul circuits across the border to the United States. So if you want to peer with the two incumbent networks, you have to buy international transport from them to get to the exchange points where they peer. And Australia did the same thing. Telstra in Australia would only peer in Los Angeles or Hong Kong for a long time. So big incumbents, if they are not regulated and not disciplined by competition, will play a lot of these games that make it almost impossible to be profitable as a competitor. And ultimately, this can only be answered through more competition. Ultimately, this is a political question of whether politicians will work for the benefit of the people or whether they're going to work for the benefit of an incumbent phone company.
So in a nutshell, the answer is the answer is that you can't regulate. This is not a problem you can solve through direct regulation, is it?
You can solve it through regulation, but you have to have the political will to do that. And most countries, it's taken a lot of time and effort to get to the point where the regulator will really work for the people rather than preserving an incumbent's monopoly. So if you have a good regulator, you should be able to get them to do the necessary work to solve that problem, but it's not easy.
Okay. Next question from Dorothy Okello. There seems to be a question on spectrum.
Well, I can speak generally right now to what's happening in a lot of countries. The regulators are saying that temporarily they will lift restrictions on the transfer of spectrum between operators, mobile operators, and that they will reallocate unused areas of spectrum into the GSM operators as a way of temporarily increasing capacity on the radio frequency spectrum for the mobile operators. But interestingly, it's not a good thing to do that on a permanent basis, right? It needs to be temporary because they're waiving a lot of the due diligence and business requirements that would normally be in place to make that happen. So you don't want to tempt operators to take advantage of that, thinking that they're going to get to keep it forever. You want them to only take that if they can actually use it now.
Okay. Next question is, any strategies for competitive local fiber, that is rollout, ownership, maintenance of the last mile, and upholding open access principles? That's from Edwin Ombega.
Yeah. So this is something I actually teach a lot of regulatory workshops on, teaching regulators how to make this happen well. Mm-hmm. And it's a little difficult to summarize, but basically, this is a municipal problem rather than a national problem. So you need to free up cities to be able to give out permits to people who want to put fiber in the ground or put fiber on poles. And the way I tell regulators to think about it is, imagine that you're a student who has just graduated from school and you have maybe $1,000 of your family's money and you want to start a business doing internet stuff. Internet infrastructure. Can you compete with $1,000 to get started? Is there a business model that works? In a lot of countries, the answer is just going to be no, right? You spend the first $1,000 on 3 hours of a lawyer's time to look at what it would cost to get permits, right? And the answer is going to be, sorry, no permits are available to you, right? Permits are only for a couple of companies and that's it. And that's a really bad answer, because what it means is that $1,000 never enters the economy and new infrastructure doesn't get built. But if you can create a regime, a regulatory regime, in which that $1,000 allows that kid to go buy a little bit of fiber and get together with their friends and dig a ditch and put the fiber in the ditch and connect up to the exchange point and connect like one new city block to the exchange point over fiber, and then sell off the strands in that cable to a bunch of people who compete over it. Now suddenly you've got competition in one city block where there was no service at all before, right, other than mobile. So this is doable. It's just not doable if you think everything has to be expensive, right? A counterexample, I saw a regulator in Eastern Europe decide that they were going to introduce mobile competition and said that there was a second license available, but to get that license, you had to, on day one, have a cell everywhere the incumbent had a cell. You had to, on day one, have 4,000 cells, right?
Whoa.
That's crazy, right? It's not a way to, what that ensures is that the only companies that can possibly do that are big companies from other countries with a lot of cash who are going to need to take that cash back out of the country, right? It's not a way to to support your own economy.
Okay, I'm going to skip. I'll get back to Enoch's question, but in some countries we notice that those running ISPs are also working on implementing IXPs, working on DNS infrastructure as well, plus data centers. Is this normal? But I think this specifically goes against the argument of having carrier-neutral data centers.
Okay, so I think we need to split out the idea of an exchange point from the data center and so define the roles here. So an exchange point is really just an Ethernet switch and a club of people who agree on a bunch of rules. And the club is made up of internet service providers. So the internet service providers are also some of the natural constituents for a data center. And a data center has a lot of useful facilities that an IXP can take advantage of. And having an IXP inside a data center means that a lot more people will come to that data center. So you very often find IXPs inside data centers. The data center operator gives facilities for free to the IX, because if the IX is located in their data center, it draws customers and makes them more successful as a business. So that's a very common model. Now, you also, in some places, find that internet service providers build data centers. Sometimes they're doing it for their own needs because they want to be able to sell a service. Sometimes they're doing it and trying to make them look as though they're like a carrier-neutral data center. But people aren't really going to believe that if they understand the market. Nobody wants to get trapped in a data center that belongs to a carrier that is not one that they want to be a customer of, because they're going to wind up having to buy more services from that carrier than from their competitors. So there's no problem with ISPs building data centers. ISPs collectively are the ones who build exchange points. But ISPs, you don't want a market in which all the data centers are owned by ISPs, right? That's where things get problematic. You see that in Chile. In Chile, you've got a lot of ISPs, a lot of really good competition, but the data center market basically consists only of non-neutral data centers. And so people wind up having to pay a lot extra to host things in a bunch of different data centers in order to have access to different networks.
All right. Thank you very much. So to everyone who attended, thank you for coming. I hope you've learned as much from this as it's been fruitful for us putting together. And I'll end up by saying, there's an African proverb that says that, unless a man plants a tree knowing full well that he'll never sit under its shade, nor eat of its fruit, the village shall never grow. So unless a man plants a tree knowing full well he'll never sit under its shade, nor eat of its fruit, the village will never grow. Some of these things you might not find an immediate benefit to yourself, but you do it because that's how you boost the critical internet capability for your organization, for your country, and for the continent. Thank you very much. God bless you. Stay safe. Wash your hands for 20 seconds. Stay home if you can. Bye.